Imagine a flash, so impossibly bright, it briefly outshone every star in every galaxy combined and then vanished. It came from somewhere we can't fully explain, leaving scientists scrambling for answers. For centuries, humanity has gazed at the stars, wondering if we were alone. Now, we're not just wondering, we're listening. And sometimes, the universe yells back in the most bewildering ways. This isn't about little green men or even common stellar events. This is about fast radio bursts, or FRBs, cosmic phenomena so powerful and so mysterious they might just redefine our understanding of the universe. We're going on a journey into the unknown today, into the very nature of space and time, to uncover a signal that broke all the rules and still baffles the best minds on Earth. Stick around, because the truth, or at least our closest guess to it, is wild. Our story begins in 2007, when a team of astronomers sifting through old archival data stumbled upon something truly extraordinary. It was a radio signal, lasting mere milliseconds, but packed with more energy than our sun unleashes in an entire year. Think about that for a second. Our sun, a giant thermonuclear furnace, constantly blasting out energy, takes 365 days to produce what this cosmic blast did in the blink of an eye. This wasn't some faint whisper from a distant star. This was a scream from across billions of light years, a shout so loud it made every other known celestial event look like a gentle hum. They called it the Lorimer Burst, and it was the first fast radio burst ever detected. Since then, hundreds more have been found, each one a fleeting enigma that appears out of nowhere and disappears just as quickly, leaving a trail of questions instead of answers. What makes these bursts so captivating, so utterly perplexing, isn't just their immense power, but their almost impossibly brief existence. We're talking about events that last just a few thousandths of a second. Imagine trying to catch a photograph of a hummingbird mid-flight in the middle of a lightning storm during an earthquake. That's the kind of challenge astronomers face. The universe, in its infinite wisdom, seems to be playing a cosmic game of hide and seek, and these FRBs are its most elusive players. For that fleeting moment, that fraction of a second, the signal from these FRBs truly did outshine entire galaxies. Not metaphorically, but literally. If you could see radio waves for a millisecond, the spot where an FRB went off would be the brightest thing in the observable universe. Then, just like that, it's gone. This incredible power, combined with their fleeting nature, makes FRBs incredibly difficult to study. It's like trying to learn about an animal by only ever catching a glimpse of its shadow. Scientists, however, are a persistent bunch. They've built new telescopes, developed sophisticated algorithms, and dedicated countless hours to listening intently to the cosmic static, hoping to catch another one of these ephemeral shouts. The challenge isn't just detecting them, it's pinpointing exactly where they come from. Imagine trying to locate the source of a single, instantaneous flash of light that happened billions of miles away. It's a monumental task, but every detection, every new piece of data brings us a step closer to understanding. One of the first big breakthroughs was in 2016, when the Arecibo Observatory managed to pinpoint the location of an FRB to a dwarf galaxy 3 billion light-years away. Even more astonishing, this FRB, designated FRB 12E12, repeated. This was a game-changer. Until then, scientists thought FRBs were one-off catastrophic events. But a repeating burst? That suggested something was still there, something capable of producing these monstrous flashes over and over again. This discovery opened up a whole new can of worms, sparking intense debate and a flurry of new theories. So, what exactly is creating these colossal bursts of energy in such a ridiculously short time frame? The immediate questions are profound. What kind of celestial body or event could generate such mind-bending power? The possibilities are as diverse and wild as the cosmos itself, each theory trying to grapple with the sheer scale of the energy involved. One of the leading contenders involves highly magnetized neutron stars, specifically a type known as magnetars. These are the super-dense, rapidly spinning remnants of massive stars, packed with magnetic fields trillions of times stronger than Earth's. Imagine a cosmic dynamo spinning at incredible speeds, with magnetic field lines so twisted and stressed they occasionally snap, releasing an unimaginable amount of energy in a blinding flash. Some scientists believe that starquakes on the surface of these magnetars, or powerful flares erupting from their intense magnetic fields, could be the engine behind FRBs. It's a compelling idea, especially for the repeating FRBs, as a magnetar could certainly erupt multiple times. In fact, a major breakthrough occurred in 2020 when a burst similar to an FRB was detected coming from a magnetar within our own galaxy. While it wasn't as powerful as the extragalactic FRBs, it showed that magnetars are indeed capable of producing such radio bursts, lending significant weight to this theory. But magnetars aren't the only game in town. Other theories lean towards far more cataclysmic events. What about the ultimate cosmic smash-ups? The merger of two neutron stars, for instance, is a violent dance that ends in a colossal explosion and the creation of heavy elements, potentially generating an FRB in the process. Or perhaps a black hole consuming a star, ripping it apart with its immense gravity, could trigger such a powerful radio outburst. These scenarios fit the sheer energy output of FRBs, but they tend to be one-off events, making them less suitable for explaining the repeating bursts. The sheer variety of possibilities highlights the complexity of this cosmic puzzle. Some even wilder theories suggest FRBs could be the result of exotic particles, or even, in the furthest reaches of speculation, a technological signature from an advanced civilization. While the latter is a very long shot, it underscores the profound mystery these signals represent. For now, the universe isn't giving up its secrets easily, and we're left to piece together clues from these fleeting, powerful signals. The fact that these signals originate from somewhere we can't fully explain isn't a sign of defeat. It's the engine of scientific curiosity. It acknowledges the vast limitations of our current understanding and fuels the relentless pursuit of knowledge. Every unanswered question about FRBs is an open door to new discoveries, a prompt for new telescopes, and a challenge to refine our models of the universe. What we thought we knew about extreme astrophysical events is constantly being rewritten by these mysterious bursts. This cosmic truth we promised isn't a neat, packaged answer. It's something far more profound, the realization that the universe is infinitely more dynamic, violent, and utterly strange than we ever imagined. The existence of FRBs reminds us that there are forces at play, events happening on scales we can barely comprehend, that are waiting to be uncovered. They are signals from the edge of our knowledge, pulling us forward into a new era of cosmic exploration. Every time an FRB flashes across our detectors, it's like the universe is sending us a postcard from a realm we haven't quite mapped yet. A realm where entire galaxies are outshone by a momentary spark. The journey to understand these enigmatic flashes is far from over, and with each new observation, each new theory, we inch closer to deciphering the universe's loudest whisper. If you're as fascinated by these cosmic mysteries as we are, hit that subscribe button to join us on our next journey into the unknown.